uh, ask you to move to our case study that we did hydrographic survey at Suramadu Bridge, Surabaya, our city. So yeah, let's see that this is the Suramadu Bridge. Suramadu Bridge is located in Surabaya city, which actually connecting Java Island with Madura Island. And this bridge is the longest bridge in Indonesia. And there is one characteristic that makes this bridge is special, that this bridge is actually connecting two islands in very narrow strait. So Suramadu is connecting two islands with very narrow strait, like that. We call it Madura Strait. Okay, so this is actually, I want to bring you to how important the Suramadu is. So the Suramadu, what I have mentioned before, that Suramadu is the longest bridge in Indonesia. It connects two islands by a strait, you know. And then the construction took 6-year long construction time. I mean, like, it starts in 2003 and finished in 2009. The bridge length itself is around 5 kilometers, in particularly 5,400 meters. And then after we know that how important the bridge is, the question is how to manage, you know, like how to manage the bridge. So it could be lifelong bridge like that. So this bridge actually consists of causeway, approach, and also main bridge. It represents 121 bridge piers, and the type of the bridge is cable stayed, you know. And then after that, we want to focus to the topic of scoring, you know, or in some way we call it erosion around the piers. The piers are in Indonesia is called, what is that? Tiang pancang jembatan in Indonesia. So in English we call it piers. And there is a phenomenon around the piers that it could be sedimentation or it could be scoring or erosion. Now, by using hydrographic data, hydrographic result data, we could analyze the number of scoring, the number of sedimentation around the piers right now. Okay. After that, this is the acquisition data. We took 2 years data from our hydrographic survey camp. So it's actually this activity is the capstone design of ITS. In 2 years, we did the survey, hydrocam survey in around Suramadu Bridge. We took the first year in July 2024 and July 2025. It's actually one branch survey, including topographic survey, hydrographic survey, and also aerial mapping. But in this research, we want to focus on the hydrographic survey only. We were using this instrument at that survey. We used the multi-beam echo sonder of Norbit, EWBMS, and also WBMS X over there. From this specification, I want to highlight that we want to make sure that the instrument that we use in 2 years is actually similar. It must not be the same, but it has to be similar. I mean, in technical specific, you know, like the frequency, the wavelength, and etc. So we have to make sure that this is the similar instrument that we use in 2 years. So by using the similar instrument, we can compare and we can analyze the result, right? Because it took at the same time, July, and it took at the same area, which is Suramadu Bridge. And this is the result. The first one, we want to focus on the pier 46 and pier P47 over there. you could see that P46 and P47 is actually located in the center of the bridge. So it must be the most destructive piers, right? It must be, I mean, like in logical way, it must be destructive, impactful piers due to the ocean current, due to the sedimentation, and etc. And also, I want you to focus on the same wave that we have found at the third rectangular over there. There is a sand wave phenomenon. And then we want you to, I want to compare the depth profiles of 2024 and 2025. We make two vertical slice over there, A line and B line, and then we compare the depth, the depth result of A and B profile. We could see that there is a red and blue over there. Okay, sorry, it does not work. There is a red and blue lines over there. The blue line represents 2024 and the red line represents 2025, the depth survey. So for the case of P46, it's not really that change. I mean, like there is no change in P46 and P47 in both 2 years. And this is the result of P47. Well, actually, it's more, it's more different than P46 because you could see there is a difference between red and blue lines over there, red and blue lines. So from this result, we can conclude that there is that P47 is more. It changed more than P46, some kind of like that. And then the third case is about the sine wave phenomenon. It's actually interesting. Because you could see that at the bottom picture over there, I also represent the red and blue lines, represent in 2 years, 2024 and 2025. Well, you could see that there is, significant change both in 2 years. It means that the dimension of sine wave, it's actually changing from 2024 and 2025. And it indicates that there is strong current around the bridge, and it could affect the health of the bridge itself. I mean, like, by using the hydrographic data, we could see that there is, threat. We could see a threat around that bridge. And then, let's move. After we knew the hydrographic part, we also did the hydrodynamic models to know the current condition in 1 year. So illustration at the right picture over there is the illustration of ocean current in 1 year. Around P46, and this is the result of main bridge 46 and main bridge P47, and also the flood current for one whole year. From the picture there, you could see that there is a scoring area and sedimentation area that represent by red and white circles. From the result, you could see that at the west and east result, or circle A and circle B, is actually sedimentation, and for the northern part and southern part, it happened the scoring phenomenon. Okay, because the time is up, then I could sum up the result then. This is the sedimentation and scoring, right? Sorry. Because the graphic is actually start from 0, and when it goes up, then it's sedimentation, and from the 0 to go down from the scoring, it's negative value, then it's scoring. Sorry, I'm flowed by the moment. Okay, To sum up this, I want to give you take-home message. There are 5 messages. The first is acoustic waves will propagate through water, making them perfect for underwater remote sensing. And then the second one, the SNR directly indicates the clarity and reliability of sonar data, which high SNR, it could be accuracy for mapping. And then higher frequency yield higher bathymetric resolution, but more noises like that. And then underwater acoustic remote sensing can be used for bridge score monitoring. So yeah, in construction way, we could use hydrographic data. And then combine underwater acoustic remote sensing and hydrodynamic modeling prevail complete understanding of underwater dynamics. The last but not least, we want to thank our partner, which is Hydronav Teknik Katama, because this is the main sponsor of geomatics engineering student hydrocamp in 2024 and 2025. So by the company over there, if you want to be our main sponsor in our next agenda, I will present your result in the next conference and forum like this one. So, okay, thank you very much and good morning.
Okay, let's give a big round of applause to our speakers. Thank you, Miss Irena. Thank you for your presentation. And now, we'll continue for the second speaker from Taiwan. Let's welcome Tianyin Chou, Director, Distinguished Professor, GIS Research Center, Fengsha University.
Hi, morning. This is my second presentation. I did one presentation yesterday. So today I'm going to talk about from geospatial infrastructure to smart mapping and something integrate lots of different kind of issues. And I'm the one of the vice president of the Chinese Federation of Surveying and Mapping. And I'm also the professor in Fengsha University in charge of the GIS Research Center. And also I serve as OGC Asia Foreign Chair and one of the EPIFITA Secretary General. So let me start with my talk, and thanks for the opportunity to arrange me to talk about some of the most recent finished project. The challenge we're facing now is there are so many growth of geospatial data sets from different kind of sensors, including satellites, drones, aircrafts, lots of things, even in the ground Internet of Things, those kind of sensors. So the technology is how we can use the AI, how we can use the edge computing technology, not to use only by those kind of analog sensors, but make it smart. We say smart sensor, smart camera. And they can do the real-time analysis, decision making. And also, one of the most recent developed the data cube capability, because lots of data sets are not just as a normal one. So because they're temporary information. So we need some kind like data cube technology. And there are lots of different kind of application. I will show to you some of the application. And the vision is to become smarter and faster integrated solution for sustainable governance. So there are so many data sets, There are mediums of the satellite in the near future because the orbit satellite, especially for the communication, require thousands of the satellites to orbit in the low orbit one. And there are so many resources, satellite, and lots of different kinds of satellite, aircrafts, and drones, and ground sensor. There's so many data sets. And because of those kind of data sets, is getting more and more sensors. How we can make those kind of sensors be smarter? For example, how we can just very easily to train the data sets like the left-hand photogrammetries, images, automatically delete the vehicle on the road because we need to take out the vehicle. So just automatically use the AI trained large language model, then we can just easily train those kind of AI model to delete the vehicle very simply, just in a very quick, and also not only to delete it, is we're not going to make just something like a mask, but we need to make something was truly on the ground. So ask the AI, use the historical information, ask the AI, use some kind of algorithm to calculate or even to count what's the real, like it should be this kind of symbols under those kind of vehicles. So when we take out the vehicle, the system will automatically refill what it is, depend on the historical information or depend on the new new calculation things. Like just very easy to take out those kind of vehicle and make it as exactly the shapes it's supposedly to be look like. So this is something we can ask the AI to do. And this is also one of the drone carry the thermal sensor, capture some images during the night, just along my campus. And so we can ask the ULO to direct calculate or direct identify if it's a car, it's a truck, or it's an automobile, or what it is. And what about the traffic? What about the volume? Everything. So all the sensors become smarter and smarter. Then the AI is beyond the screen into the physical world now, because lots of things are changed. And also, because of those kind of assets, in Taiwan, the government worked together with the university and private sectors, try to develop a kind of federation of the data cube. Those kind of data cube include all the different kind of sensors, like satellite, aerophoto, DEM information, and or even the simulation model. Because it's not only the data set, we need some kind of algorithm to calculate the model directly, get the result, and let people to realize and understand what the result is. So in Taiwan, there's a big project applying the data cube for resolving some kind of limitation in such a kind of huge data sets and data information just coming up to the ground or coming up to the world. So we can very easily to develop some kind of things and just query any kind of period, and we can ask for any kind of satellite image or anything, like the ground sensor for the air pollution or anything. So it's very easy to get this kind of information. So we just pick whichever the ground area and ask the entire information to just get very easy. Like this is used at QGIS. QGIS is a free open source for the GIS. So use the QGIS, and then we can just directly operate our operation and ask the system itself to identify what it is or to get access for some other satellite information or some other information on the ground. So this is a big project in Taiwan now. So we can use lots of different kinds of data sets, lots of data cube technology, and just use very simple QGIS and to develop the entire systematic systems. And just look at this one. Normally we have an APP to identify the flight, the airplane, where it is, but it's all showing in two-dimensional. But how we can identify what the pilot looks at the ground? So we need to recruit the previous satellite image or ground information or the aerial photo. So we use this kind of technique to identify where the plane was flying through and how the pilot, what the pilot will look like because of this kind of elevation. So the pilot will be able to look at the entire area and what the area will look like. So some of the satellite image are the previous one because it's really hard to get a real-time satellite image. But it's close enough because this is like the satellite image or the air photo like last month or last year. So we can still identify what the pilot is looking at. Of course, I'm showing to you the commercial vehicle, but we're not only do the commercial things. And also, we can very easy to use This is a kind of demonstrate how we can very easily use international standard and to try to create your own weather report platform. Just like there's a very famous app called Windy. So we can just access all the international standards, weather, meteorologic satellite information or ground sensor information from different countries. And we can use one of the model from the US, the NOAA model. So use the NOAA model and use all the kind of sensor information or the kind of latest open released, open data information. We can create our own weather platform, and we can make a prediction as where or how the typhoon will be react, because we follow the NOAA, the NOAA from the US, his model. So if I use the other model, like in Taiwan, normally we counter the typhoon. Each year there will be 10 to 12 typhoons coming to Taiwan. Every country has different prediction. Why can't we just make our own prediction? We can even just create our own prediction, depend on everything is open, because even the model is open for the NOAA typhoon model. Nowadays, I was teaching the GIS and remote sensing on the campus. Previously, I have to show to the student how you can classify, how you can registration, rectification, classification by the satellite image to identify what kind of vegetation, what kind of like the ground building, those kind of information. But now we use AI. So AI trained to learn, and the AI give the information directly, just in seconds. So the students, they don't have the anxiety to learn what was the theory on the back. Because they can use the AI, just train the AI. AI will identify everything directly. So there are so many different kinds of sensors, and in Taiwan, most of the sensors, especially is related to the disaster, is follow one of the OGC standard. It's called the Sensor Things API. Because of that, so in Taiwan, every governmental officers, they can follow the common alerting protocol. It's also one of the international standard. And the government can release the kind of warning alert to anyone who has a cell phone, use a cell broadcasting technique, or anyone who has some kind of communication society, like the line in Taiwan. So can use the line to inform everything if something being identified from the camera by the flooded or some traffic. So there's thousands of those kind of camera and identify information and get back to the emergency operating centers and send out those kind of information. So this is one of the graph I showed yesterday. I'll show today again. Like on the left-hand side, that's a geophone. It's received the high energy response from the high mountain area. And so we can recognize that there was a very serious landslide in 10 minutes before. After 10 to 20 minutes, on the central video, we'll be able to identify this is one event of the debris flow in Taiwan, in one of the mountain area. So this has really happened in Taiwan during the summer season, and we can use these kind of things to identify the debris flow, and we have lots of different sensors just along the entire creek. So on the entire river basin, we put so many different kind of sensors, and we use lots of information to identify everything. And even for this one, this is a machine to machine. If the sensor, the camera found out there's something happened, it will automatically change from the green light to the yellow light. And also it will double check with the other sensor, with the rain gauge, with the velocity, with the volume, to make sure it's not one sensor malfunction. So make sure this is really happening and change to the red light. So this is a things machine to machine. So now we try to have the AI is smarter enough to be identified by lots of things, like the, can you hear that one? Like the AI automatically identify what about the thrust depth from 10 centimeter to 11 to 12, depend on the wheels of the cars, and the color of the water is different because of the splash water or the frost water. So identify the frost depth directly, identify the frost area, And also everything, we can use the same kind of standard to put the boundary information directly into the Google Earth. The Google Earth is a kind of open thing. It receives the WMS, receive all the kind of information. So directly I can use the Google Earth to identify where the boundary is. So this one change, if this one change. So if the boundary change by the AI edge computing camera, automatically this one will also change. But this is Google Earth, so it's a free one. And not only for those kind of sensor, but in Taiwan, also to identify any kind of accident. For example, this is something real happened just last year. Last year, one of the industrial area, one of the chimney being exploded. So it's a toxic chemical. It's a toxic one. So automatically, the entire system calculates what kind of toxic air it is, and depend on the wind chill and the wind direction and the humidity and lots of information. So it automatically send the alert to all the people who live on the downside. So when we do this, we can use a 3D simulation automatically and analysis to try to calculate what kind of wind chill, what kind of the influence will be on the downside. So this thing is being to the newspaper. So it's a real thing. It's a real thing because we identify lots of things. So in Taiwan, for the disaster prevention, there are so many different kind of alerting things, even for the digital twins application. Because in Taiwan, 7 million out of 9 million buildings in Taiwan has already have this kind of level detail information being built up by the central government. So those kind of information, we can use it and we can really identify or use this kind of view to identify if there are 300 millimeters of precipitation, where will be floods. So it will be very easy to be identified. And one of the last projects we're doing now is to work together with international organization, try to use satellite information, aerial photo, different kind of information, and also the ground sensor to identify directly which vehicle it is just in the airport. So this is one of the international projects we've been doing together with different international organizations and try to use so many different kinds of information from the air, from the ground, and to identify the real information. So this is like in the Kaohsiung city, we use a three-dimensional thing. We use the traffic information. We use all the sensors from different local traffic conditions and to identify the entire traffic situation in the city, in the Kaohsiung city in Taiwan. Because everything, so the smiling curve is the things I would like to mention about. Try to use the intelligence, try to have a surface, but we have to have a very good marketing strategies. So this is become an open and also sharing society. So the key takeaway is the AI and data cube. And for the future, I would expect more and more international and cross-sector collaboration. And also call to the action, like I'm from the university. So not only for the education, but also for real project and lots of different exchange can be happen just following the Indonesia with Taiwan summit. Thank you.
Thank you, Mr. Cho. Next, we're going to have a panel discussion that will be moderated by Roger Maniur Simanjuntak, STMSC. But while we're preparing the stage, may I ask how many you are excited for the panel discussion? Nih, kurang semangat nih ya. Have you guys already breakfast? Okay, when I said Fit Easy 2025, salah deh. Fit Easy 2025, you guys have to answer luar biasa, gitu ya. Mister, can you repeat my... Jadi bingung kan? Oke, Fit Easy 2025. Belum semangat. Sekali lagi, Fit Easy 2025. Okay, and the stage ready. I wanna, apa nih? Bingung. We're going to have a final discussion that will be moderated by Bapak Roger Maniur. Oke. Kasubdit Informasi Geospasial Tematik Multiguna. Oke, the stage is yours, Bapak.
Ladies and gentlemen, distinguished guests, good morning. I hope you enjoy the time in Malang City. My name is Roger Maniur Simanjuntak. I serve as a Vice Director in Thematic Directorate in the Ministry of Agrarian and Special Planning, National Land Agency. Today I will lead the panel discussion, and I will introduce 3 speakers from our ministry. The first one is Mr. Farid Hidayat as a Director of Survey and Base Map. And then the second one, I will invite Mr. Agus Apriawan as a Director of Thematic Mapping. And the last one is Mr. Yogo as a Vice Director in Cadastral Directorate. Yeah. Okay. So I hope all of you can get a benefit from this panel discussion, especially from the Taiwan Summit, the representative from Taiwan, because today actually the speaker is our Directorate General, Mr. Virgo, but Pak Virgo today has an urgent meeting in Jakarta, so we will deliver the message from him. So before I started the panel discussion, the first one I will explain to you about the central role of our ministry. The Ministry of Agrarian and Spatial Planning, National Land Agency, plays a central role in ensuring legal certainty of land rights, and then assessing land value, regulating land use and spatial planning, and providing a strong spatial data infrastructure. So all of these efforts are crucial in creating a secure, transparent, and sustainable land administration system in Indonesia. And the Directorate General of Survey and Mapping actually has 3 Directorate Technical. So it has 3 units. The first one is Directorate of Base Map, which lead by Mr. Farid. And then the second one is Directorate Cadastral. The director is Mr. Handy, but he cannot attend this meeting, so he gave a presentation to Mr. Yogo, and the last one is Mr. Agus Apriawan as a Directorate of Thematic Mapping. So we have 3 technical units. Both of them will explain one-on-one of all the related topics that they will share to all of you. So the first one, I will give the speaker to Mr. Farid as a director of BESMAP. Time is yours, Mr. Farid.
Oke, thank you Pak Roger. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera buat kita semua. Om Swastiastu, Namo Buddhaya, salam kebajikan. Sao Sang Hao, Wo De Ming Si Faride. Wo Bu Hui, Suo Putong Hua. Unfortunately, I cannot speak English too. Maybe this presentation I will provide in both in Bahasa and half English, because my last time taking English TOEFL score, English TOEFL test, my score is below 440. Okay, let's continue to the first slide. I continue. Yesterday, Pak Virgo has already which one? The other one?
Slide-nya Pak Farid.
Yeah. Yesterday, Pak Virgo has explained to us that our ministry, Agrarian Affairs and Spatial Planning, has 4 pillars. The first pillar is land tenure, and the second pillar is land value, and the third pillar is land use, and the fourth pillar is land development, which every pillars hold by several institutions in Indonesia, and the Agrarian Affairs National Agency hold the first pillars in land tenure. So from this discuss this morning, we are focused on the first pillar, and maybe sometimes we will discuss about the other pillars. Okay, this is our presentation that from my directorate. Our duty is to provide the base map to our institution to assist Pak Yogo and Pak Agus to undertake their job. Our duty is to build the base map of various scale and various class of the base map. Sometimes we use the satellite imagery, and sometimes we use aerophotogrammetry, and also sometimes we use drone. And the last time we try to build some database in 6 cities. We try to create a leader map to gain the 3D map of some cities in Indonesia. And today we have planned to fly our LiDAR sensors in Kota Cirebon in West Java. We hope in next 20 days we will have the 3D models of Kota Cirebon completely. We will wait for the result. Okay, they can continue next slide. Back. Yeah, this is what I have just explained to us. The foundation of the land information, cadastral and topographic data, geospatial infrastructure is the availability of the base map. Yesterday, Pak Virgo has explained to us that we have already achieved many successful story about how to map the land parcel in Indonesia. Pak Virgo said that we already mapped almost 123 million parcel from the target 126. But unfortunately, from the achievement of the land-based map is still quite far from the complete, because we already provide around 25% than the target. So we have to accelerate the gap to make Indonesia completely to make Indonesia complete in base map. Okay, next slide. Here the achievement that I just explained. Nowadays we have 20 million, 70 million hectares of the target of the area APL. What we say in APL in English? Non-forest area. We have target non-forest area 70 million hectares, and the coverage of our land-based map is about 40 million and 700 etc. hectare, and the area which not covered yet by our base map is around 26 million hectares, and the availability of the high resolution of the base map, we still have big gap there. You can see from the below right of the diagrams, we just we only have about 15 million hectares of the high quality of the base map, and the maps on the below right, you can see the index, the availability of our base map. Okay, continue. To achieve that our what we say ketertinggalan, to accelerate our achievement, we are trying to map our area, and we not only fly our aerial equipment, but also we are make kerjasama, cooperation with some universities in Indonesia. And in the next slide, we can see that we have a cooperation with 11 universities in Indonesia. We gave our drone and LiDAR to 11 universities in Indonesia. So we hope that the 11 universities in Indonesia can help us to create or build the base map, so we can accelerate the availability of the base map in Indonesia. Next, and this slide try to tell us our directorate trying to apply Geo AI in order to gain the building print in Indonesia. At the first presentation, I thought that I mentioned that we have already mapped more than 120 million of parcel, but unfortunately the map of the building footprint in Indonesia is quite far from that number. And until today, we are already delineate the building footprint about around 15 million. 15 million that if we compare 15 million building footprint then 120 million land parcel, it means that we have a big gap right there. So we are trying to accelerate the building footprint in Indonesia. We are trying to use the Geo AI. Yeah, we have some experience here, and you can see from the presentation that the step one is preparing the data, and the next we are trying to create the training model, and the next step is to extract the building print, and the next one is editing the result from the extraction, and at this section is quite challenging because we have some situation there which is we have a situation like omission, commission, and some some of the result need to edit further, and even sometimes the GeoAI defines that this one is building even though that in the area is not a building. We are struggling to make a good or better a better training and we hope that in 1 year or in 1 or 2 years ahead we will have a better GeoAI to build the building footprint. And the last slide is we also try to detect the geographic unsur geografik di dalam peta dasar. We already generate like road, body water, and some and other geographic feature. From that experience, we still to improve the GeoAI, and we hope that in next 1 or 2 years we will have a better result. Okay, thank you very much. Sini.
Siapa dulu? Okay, so the next speaker is Mr. Yogo. The time is yours.
Thank you, Mr. Moderator. Good morning, Zhang everybody. Okay, I have a special request from our Director General, Pak Virgo, to present about our pilot project in order to develop our 3D cadastre. As we know, our Director General, Pak Virgo, has a very great vision to mapping all the high-rise building all across Indonesia, and then continue to build the digital twin, and then to display in our geoportal. But however, as we know, every great vision needs small step. Okay, next. This is our data. We have about 630,000 strata title all across Indonesia in 800 apartment. So in this about 2 months our pilot project conduct, we already collect the data about next. About 18 apartment ya. So this 3D model also we display in our geoportal. We call it Bumi, that our very great, big geoportal that everybody can access in our website. And then next, this is the result. We have 18 apartment, and that one in Makassar, in South Tangerang. Next again. Next. Okay, all the 18 apartment, and this is our geoportal. We call it Bumi, so everybody can access. Mungkin bisa di play. Oke. Coba diklik layarnya tadi. Yang di Google Slide tadi kayaknya. They just can add and then view the common or a private space like that. And then the people so can see the attribute data, tadi such as addresses or number identification, and then they so can access the cross-section picture. So next again. This is the 18 city that we collect the data. That are from Batam, Makassar, Surakarta, Surabaya, Tangerang, Padang, Semarang, and then Cilacap. Unfortunately, Malang, we don't have the data. So all this data is collected by our land offices, and then this next again, next slide. This is our general system workflow. So the workflow is the data is collected by the land officers, and then they standardize it, followed by entry the data attribute, and then process into 3D model. The model are stored in the CTJSON format. So why we choose CTJSON format? Because one is the smaller size, compatibility with JSON, and then its simplicity and readability. After that, the data is uploaded in the Bumi, and our officer in the office verify it, and if the result meet the standard requirement, the 3D model we publish in the Bumi application. So, ladies and gentlemen, that's all the background and the review about our 3D cadastral model in the Indonesia. Thank you very much. 谢谢.
Okay, thank you, Mr. Yogo. And the last one, Mr. Agus, time is yours.
Okay, thank you, Mr. Roger. Morning. Jadi biar adil tadi sudah dua-duanya paparannya bahasa Indonesia tapi ditranslitkan bahasa Inggris. Saya balik, paparan saya bahasa Inggris tapi saya bicaranya bahasa Indonesia biar yang dengerin juga bisa paham gitu ya. Baik Bapak Ibu semuanya, seperti yang sudah disampaikan tadi, bahwasannya di Direktorat Jenderal SPPR itu ada 3 direktorat gitu ya, yang tidak terpisahkan menjadi satu kesatuan, di mana Pak Farid itu adalah direktur atau direktorat lead direktor yang menyiapkan base map-nya. Kemudian di Direktorat Kadastral itu adalah yang mengisi kepastian luasnya, dan terakhir di Direktorat Tematik adalah direktorat yang mengisi isi di dalamnya, baik itu bagaimana pemilikan, penguasaan, pemanfaatan dan penggunaan land-nya, tanahnya gitu ya. Baik Bapak Ibu, lanjut. Nah, ini kemarin sudah disampaikan sebenarnya oleh Pak Dirjen, Pak Virgo, bahwasannya ruang bermain kita di kementerian ada 4 ruang yang diisi oleh kementerian secara keseluruhan gitu ya. Terlihatnya besar banget. Ada 4 ruang land tenure. Selama ini kalau kemudian kita ibaratkan seperti lapangan bola, ruang ini sangat kecil banget. Kecil banget. Main bekel seperti main bekel tetapi di lapangan bola gitu ya. Kecil banget. Karena apa? Karena selama ini belum ada pengelolaan terhadap data yang kita miliki yang begitu besar gitu. Lakukan pengolahan sehingga kemudian masih yang bisa memberikan manfaat yang luar biasa kepada masyarakat Indonesia gitu ya. Nah, saya nggak usah jelasin, intinya inilah ruang-ruang yang kemudian menjadi tugas pokok dan fungsi Kementerian ATR gitu ya, dalam memberikan atau mengakuisisi data atau tugas dan kerja dari Direktorat Impor Tematik kita yang kemudian menjadi sebuah produk peta informasi geospasial tematik gitu ya. Ada beberapa, ada peraturan presiden tahun nomor 39 tahun 2009, kemudian ada peraturan presiden tentang One Data Indonesia, satu data, kemudian ada peraturan presiden nomor 23 tentang dasar kita bekerja di Direktorat Tematik yang kemudian coba kita kaitkan dengan beberapa kegiatan-kegiatan astacita dari pemerintah sehingga menjadi satu kesatuan yang bisa menciptakan atau memberikan informasi kepada pemerintah bahwasannya data kita, negara kita luar biasa gitu ya, dari sisi potensi dan sebagainya. Nah, lanjut. Nah, Bapak Ibu semua, kalau kita bicara lebih dalam tentang direktorat tematik, memang kita punya 3 unit ya, unit yang ada di dalam bagaimana sebuah penyelenggaraan tematik. Yang pertama adalah unit produksi gitu ya. Unit produksi, seluruh dirjen teknis yang ada di kementerian itu adalah unit-unit produksi gitu ya. Kemudian kantor pertanahan, kantor wilayah gitu, itu adalah unit-unit produksi. Kemudian data-data yang diproduksi oleh unit-unit ini dikelola oleh unit pengelola, direktorat tematik gitu ya. Dikelola melalui kompilasi, integrasi dan sinkronisasi, kemudian standarisasi dan sebagainya sehingga kemudian seamless semuanya datanya. Ya, terakhir kemudian kita tempatkan di unit penyebarluasan, intropnya gitu ya, di intropnya. Nah, kegiatan inilah yang kemudian sudah kita lakukan gitu ya. Dalam bentuk banyak hal yang bisa diberikan kepada masyarakat. Ya, melalui portal-portal yang sudah kementerian, baik itu mulai portal bumi, kemudian ada peta dasar gitu ya. Ada portalnya dan terakhir ada IGT portal kita. Nah, lanjut. Berikutnya adalah what has been done so far gitu ya. Nah, ini yang kemudian apa yang sudah kita lakukan. Apa yang sudah dilakukan oleh direktorat tematik selama ini dalam mensupport konteks program Astacita yang selalu didukungkan oleh Presiden mengenai hilirisasi, monetisasi gitu ya. Apa yang sudah dilakukan. Nah, kita coba lakukan beberapa proses project gitu ya, pembuatan beberapa tema-tematik, peta-peta, dan perlu memang masih sentuhan-sentuhan. Semua ini beberapa contoh kemarin pun sebenarnya sudah disampaikan oleh Pak Dirjen, ada beberapa contoh yang sudah kita lakukan, kita pilot project-kan gitu, menggunakan AI gitu ya. Beberapa kolaborasi sudah kita lakukan bersama Civitas Akademika dengan UGM gitu ya. Beberapa, nah harapan saya gitu ya, ke depan banyak hal dalam mimpi kita, proses hilirisasi ini kita bisa kerjasama dengan banyak lagi dunia pendidikan. Ya, kalau hari ini saya berada di Malang, harapannya adalah ke depan saya bisa teken kerjasama dengan Teknik Geodesi ITN Malang untuk membantu apa yang bisa disumbangsikan untuk perkembangan tematik hilirisasi ke depan gitu ya. Teman-teman di ITN Malang mana ya? Gitu ya. Siap ya, bantu ya. Dibantu ya. Kita kerjasama apa yang bisa disumbangkan oleh teman-teman ITN Malang untuk membantu proses hilirisasi dan monetisasi tematik kita gitu ya. Lanjut. Nah, ini ya beberapa contoh Bapak Ibu. Terus lanjut aja. Kemarin sudah disampaikan oleh Pak Dirjen. Lanjut aja Mas. Terus lanjut gitu ya. Oke. Nah, yang paling kemudian sekarang menjadi sedikit seksi gitu dan menjadi atensi pimpinan termasuk juga Bapak Presiden, bagaimana ke depan kita bisa melakukan kerjasama kolaborasi dengan pemerintah daerah dalam konteks penyatuan data pertanahan dengan data perpajakan. Nah, ini sedang kita lakukan sedikit formula-formula, sentuhan-sentuhan AI juga di situ sehingga kemudian ini segera bisa kita wujudkan. Piloting project sudah kita lakukan ada di beberapa tempat, ada di Bogor, ada di Tangerang Selatan, ada di Pangkal Pinang, ya, dan banyak lagi provinsi yang sudah mengirimkan surat ke kami untuk segera melakukan join gitu ya untuk penyatuan data ini. Lanjut. Nah, Bapak Ibu ini yang terakhir karena sudah diingatkan 1 minute gitu ya. Next yang kita lakukan saat ini untuk mendukung hilirisasi adalah kami sedang menyusun sebuah peraturan bagaimana hilirisasi dan monetisasi ini khusus data pertanahan dan ruang gitu ya yang kita miliki itu bisa dimanfaatkan, bisa diolah, bisa disatukan dengan data-data sekunder yang ada di luar untuk membuat peraturan Menteri Keuangan tentang jasa akses layanan informasi geospasial tematik yang bersifat volatile. Ya, ini sedang kita susun, mudah-mudahan nanti kalau hari ini saya bertemu dengan banyak teman-teman yang bekerja di luar gitu ya, bekerja di luaran, ini ada salah satu peluang yang bisa dimanfaatkan bersama bagaimana bisnis location gitu ya, bisa kita lakukan dan kita berikan sehingga kemudian sinkronisasi kolaborasi ini bisa mendukung ini. Ini sedang kita rancang Bapak Ibu semuanya, mudah-mudahan dalam waktu dekat bisa disetujui oleh Kementerian Keuangan sehingga segera teman-teman mitra kerja kita ya
future, but also all the nation future. And I hope that we can share a discussion after I ended this panel discussion. And it is a truly honor to give us time, especially for Indonesian Surveyor Association, so we can share, and I hope that we also can contribute to the development of geospatial information. Once again, thank you for your time, and I will give back to the...
Thank you for sharing for their insight. Before we move to the next session, I'd like to greet the member of CFSM. Ni hao, Tacha hao, ada lagi nih. Neman hai singfen ma, kan nggak ngerti kan? Sama. Okay, let's continue with the next speaker from Taiwan. Please welcome Mr. Fleck HCC as an Assistant Researcher Department of Real Estate and Built Environment, College of Public Affairs, National Taipei University. Tepuk tangan semuanya.
Sorry. The file? Okay, thank you. Okay, good morning, ladies and gentlemen. Selamat pagi. I'm Dr. Xuanchang Xi, and the others of my research partner, Dr. Bo Chen Ling, and the master student, Meng Ru Ling. And actually, the title of my presentation today is Relocating Indonesia's Capital to Ibu Kota Nusantara, Future Innovation Scenarios and Sustainability in a Changing Climate. As we know that Indonesia is moving its capital from Jakarta in Java to Ibu Kota Nusantara, or we say IKN, in East Kalimantan, Kalimantan Timur. Ibu Kota Nusantara means capital of the archipelago. This name is meaningful and in line with the distribution of Indonesia's territory. The figure here shows the planned development areas is about 256 hectares, 1,000 hectares, equivalent about 2,561 square kilometers. The total area is divided into government area, KIPP, urban center area, KIKN, and the development area, KPIKN. The new capital plan includes 5 phases from 2020 to 2045. and aims to create a smart and sustainable forest city. Okay, why we relocate to IKN? There could be many reasons, but we can conclude to two. The first is Jakarta's challenges, including urban congestion in population and traffic. Jakarta is one of the most densely populated cities in the world, more than 15,000 people per square kilometers. The most common sight in Jakarta is traffic jams. The economic losses caused by traffic jams are estimated to be 100 trillion rupiah each year. There are also problems with air and water pollution. Land subsidence and also land subsidence up to 25 centimeters per year and flooding. The second is strategic location. Its geologically stable location in East Kalimantan is less prone to earthquakes and tsunamis, promoting regional balance and sustainable growth. This table shows that from go back? Okay. Why? This table shows the most common disaster in Indonesia. There are floods and earthquakes. And the simulation of maximum 5 days precipitation under the 1.5 degrees C SSP2 scenarios shows that 67% of Indonesia's population face a high flood risk, while 32.5% faces extreme risk. And the photo here is a land subsidence observation station in Muara Baru, Jakarta Utara. Over the past 10 years, Jakarta has sunk about 2.5 meters, and about 30% of the area is below sea level by 2025. So, here's the news in 2025. President Prabowo instructed the minister to begin giant seawall project. The photo shows the top of the old seawall is already under the sea, and we need a new one. IKN is designed as a forest city with 65% of its total area dedicated to natural forest and marine reserves, including green and blue corridors to enhance biodiversity and ecologically connectivity. For example, in sustainability and environmental conservation, 100 renewable energy by 2045 supporting Indonesia's net zero emission. 60 waste recycling by 2045 and 100 wastewater treatment by 2035, in line with circular economy principles. And in resilience and disaster mitigation, circular and resilience systems with 10% of land allocated for food production to ensure self-sufficiency. And climate adaptation strategies such as advanced water collection system and avoiding inappropriate land use to mitigate flood risks. There are so many principles and targets, so many that. But what would happen if we put this principle into AI, for example, ChatGPT? Okay, so then we can get this forest city landscape. Almost everything is a green color. I think this is pretty good, but what do you think? Next. Okay. Well, IKN area is shielded from the volcanic and seismic activities. However, it is not entirely free from disasters. Flooding is the most common disaster in East Kalimantan, occurring 4 to 5 times per year. You can see the cause is due to the river overflow and extreme rainfall. Another type of flooding is coastal flooding. It will become more frequent due to rising sea level. Threaten ecosystem, economics, and human settlements. Second, landslides are a growing concern due to high rainfall and deforestation. Third, forest fires. In addition to drought-driven slash and burn practice, prevalent in Kalimantan exacerbate fire risk, worsened by the weak role enforcement. The paper in 2024 notes that IKN show a relatively higher multi-hazard risk, with 22% of the hazard area vulnerable to both flooding and landslides. The figure here shows the floods and landslides risk map in IKN area. When talking about the sea level change, it can be concluded into 4 parts. First is the normal expansion. The ocean absorbs 90% of excess heat come from greenhouse gases. Seawater warms and expands, contributing to roughly half of the observed sea level rise. The second, melting ice add fresh water to oceans, resulting in increased ocean mass. For instance, Antarctica only could contribute up to 50 centimeters of sea level rise by 2100 under high emission scenarios. Land water storage, it affects short-term variation in sea level change. For example, in one of the strongest La Nina event in 2010 and 2012 led to increased land water storage in US and Australia, resulting in a downward trend in sea levels. Human activities and the natural process lead to land subsidence, particularly the peatlands and the coastal areas in East Kalimantan. It could be exacerbate the impacts of rising sea levels. Oh, go back. And the figure at the left side shows the projections of rising sea levels under different SSP scenarios. By 2050, the global sea level will rise by an average of about 20 centimeters. Sea level rise in low latitude regions, especially in the tropical Western Pacific, including Indonesia, is generally higher than the global average due to ocean and climate factors such as enhanced trade wind and ocean current dynamics. And the figure at the right side shows the relative sea level change from 1993 to 2019 based on measurements from the tide gauge tower in the North Kalimantan, Sabah. You can see the individual contributions from ocean, from land, from ice and water circle, and the tide gauge chain. Okay, this animation shows the coastal flooding affected area and the SSP3 7.0 scenario from 2030 to 2050. The size of affected area in IKN approximately 140 to 210 square kilometers. It accounts for about 5 to 8% of the KPIKN development area. According to IKN's delineation, the south part of the economic and entertainment districts will be the main affected area. So, let's turn to sustainable and urban planning. First, we must prioritize the infrastructure resilience. This means building elevated structure, installing flood barriers, and creating green infrastructure like wetlands and parks in high-risk areas to absorb flood waters and minimize damage. Second, land use and zoning are key. We need to identify flood-prone areas and reserve land as natural buffers, restricting development to ensure sustainable zoning that protect IKN from future climate risk. Additionally, we must assess vulnerability by identifying critical areas like government officials and transportation networks, and ecologically sensitivity zones, prioritizing their conservation. And for the adaptation stage, such as early warning systems, flood resilience, construction standards, and even relocation plans for high-risk areas, will ensure IKN remains functional and sustainable as the climate change. Preserving natural ecosystem is vital for IKN's resilience. Discuss how rising sea levels and flooding could threaten coastal ecosystems or forest regions. For instance, inundation could degrade mangrove is a tree, critical for flood protection and carbon sequestration or flood reserves, undermining IKN's biodiversity. Ecosystem-based solutions are recommended by restoring mangrove and protecting wetlands to mitigate flood damage while fulfilling IKN's environmental commitment to a forest city. On a policy aspect, climate-informed planning is essential. This means updating building codes or standards to account for flood risk and adjusting land use regulations to prioritize conservation. Finally, stakeholder collaboration between government agencies, researchers, and the local communities is crucial to implement sustainable practice, fostering a governance model that ensures IKN's climate resilience for the future. And this page shows the future works of this research. We will try to collect more data, for example, the land use, land cover, population distribution, terrestrial and inland water protected areas, peatland in Kalimantan, and so on. And for example, the figure here shows the land use and land cover change in IKN area from 2003 to 2023. And actually, if we can use this data with the help of AI, we can generate the multi-disaster risk map, and that can be used to help the urban planning and many sites. And also, we can also study the impacts on wildlife habitats, such as Ikatan, and the proboscis monkeys. Terima kasih. This is all of my presentation today. Thank you for your attention. I wish Taiwan and Indonesia's collaboration will have a fruitful achievement in the future. Thank you.
Okay, thank you so much, Mr. C. Thank you for your presentation. Oh, thank you. Now let's continue for the speaker from Indonesia. Let's welcome Bapak Agung Indrajit STMSC as a Deputy for Green and Digital Transformation. Let's give applause to Bapak Agung.
Assalamualaikum warahmatullahi wabarakatuh. Greetings. Thank you for having me because I present this at very short notice just this morning. To be awkward, like our chairman said, I'm from New Capital Authority. I just saw the presentation about New Capital. Yes, I think the previous presentation is very interesting. And also maybe after this presentation, I will approach the presenter about how to implement that in the new capital of Nusantara. However, to complete the previous presentation, I would like to show you the latest video of the current status or progress of new capital Nusantara that just presented before. Please.
Indonesia suffers the effect of climate change directly. Our coastal areas are now being inundated by rising ocean levels. We are forced to move our capital city. In the northern coast of Java, the ocean is rising by 5 centimeters per year.
Located in the lush landscape of Borneo, Indonesia has embarked on an epic journey towards the future. The construction of the new capital city, Nusantara. For the past 2 years, the country has worked in harmony on this project, advancing step by step not only to build the nation's new capital city, but also to establish a new way of life and pave the way for a brighter future. The first focus of development is the city's main governmental zone. Through the labor of local manpower, every brick laid represents Indonesian pride and hard work. Environmental sustainability is one of the city's core values, and Nusantara boasts an abundance of green spaces which are fully accessible to the public. Residential areas created for civil servants are constructed to provide a healthy environment and promote a fulfilling and balanced life between work and family.
Fasilitas yang pemerintah siapkan menurut saya udah sangat bagus dan suportif, mulai dari tempat tinggal, kita sudah disiapkan rusun dengan fasilitas yang sangat lengkap dan modern. Lalu untuk transportasi kita juga bisa menggunakan bus dari rusun ke tempat kita bekerja.
Economic activity in Nusantara is growing, slowly but surely. Several public facilities are currently operating in Nusantara, providing accessible and high-quality services to the general public. As a sustainable city, Nusantara's energy needs are generated through environmentally friendly green energy sources. To encourage a healthy and active lifestyle, Nusantara boasts impressive recreational nature parks and sports facilities which are fully accessible to all generations. The development of Nusantara extends far beyond the city itself. The development is also focused on connecting the new capital with the neighboring cities. The second development phase will focus on expanding the city to include modern legislative and judicial office zones. After 2 years of development, Nusantara is finally beginning to take shape. However, there is still a long way to go, and progress will continue step by step.
Dengan adanya pembangunan IKN, sangat signifikan peningkatan ekonominya, infrastrukturnya, banyak keuntungan masyarakat. Begitu luar biasa menurut saya.
This will be the beginning of the nation's huge leap forward to introduce to the world our vision of a future civilization. Nusantara, a global city for all.
Thank you. I hope it completes the previous presentation. For now, at least 100. And 70,000 people live in IKN, including the local society. However, my presentation is also what we want to do at IKN. IKN as the center, capital city, we also want to be a center for high-tech and investment location that needs good and robust geospatial information. In 2025, there is new ISO that already published this year about land administration domain model. This renewal of ISO aiming for sustainable development goals and also to improve ease of doing business of its cities concerning about land and its administration. Therefore, I want to present the newly ISO that has been published this year, and also our plan to implement this ISO at IKN. I hope it will also give you more insight about the ISO itself and the IKN plan for geospatial information, especially in land tenure, land valuation, land use or spatial plan, and land permit. I made this slide and ISO with this team. This is a citizen countries that. For example, I'm with the Netherlands, Bastian, and also Peter, Anna Snetman, also from Russia, Hendrik from German, and Virgo from Indonesia also. Next. This ISO are stated as the part of sustainable development standard. Therefore, this is important, especially SDGs number 7, number 9, and number 11. This ISO should be implemented globally, and IKN plan to implement this. Next. What we aim is land tenure, land valuation, land use, and land development. My part in this ISO is ISO 19152-5 concerning about land use. This should be important for development of a city. Next. This also comply with UN Habitat statement, both in New Urban Agenda and also the Strategic Plan 2020 and 2025 this year. Next, what we want to do, the importance of this package is, for example, we have land. At IKN, this is the newly erected city should be like this. We have built road, next. However, they also have some local path or existing delineation, next. And also, we want to sell this block, for example, in several parcels. Next. And then we construct urban planning with building envelope each of the parcel. And of course, we delineate zonation of maybe one block consists of 2 zonation. Then, next. If we compare it with digital twin, we know that the building maximum, development maximum exceed or inside the limitation. So we can use this for urban planning monitoring also. Then we can make this access as violation or fine, or should be demolished for the excess or the bonus of the building. Next. We experience this in 3D spatial planning in Indonesia. Many of the buildings exceed its limit, and unfortunately, they have to be closed or to be stopped, the economic activities, or also they have to demolish. This one that we want to avoid in the future of IKN. Next. We also have online single submission that requires 3D spatial planning and also 3D cadastre. In BPN or National Cadastre Agencies, this should be part of their job as a Ministry of Agraria and National Cadastre Agencies. This requires also the standardization of spatial plan and cadastre data. Next. By implementing this ISO 19152 series, we aim also for improving ease of doing business ranking of Indonesia. We can see that land tenure, land valuation, land use, and land permit of this ISO. Next, private law space. This three space should have space. This three space should have information of Cipta Kerja, information of Cipta Kerja law.